Hello, everyone. Okay, so we are on day 2. Yes, day 2 of Unit 1. And we're going to be looking at pages 3 and 4 of our guided notes. Everything on here has to do with scientific notation. Okay, so last time we ended with question 2 that you were instructed to go through and try that out on your own. And now we're moving on to scientific notation. Okay, here's how scientific notation works. It is any number between 1 and 10 that is multiplied by 10 and then raised to some power. Okay, so this base number, we call it the coefficient. And notice that it's not a value greater than 10 and it's not a value less than 1. And then we have times 10 to some component, some power here. And depending on what these are and whether they're positive or negative, they can mean very different things. So here's an example. This first one here, we have a carbon atoms in the Hope diamond. Our coefficient is 4.6, and we're timesing this times 10 to the 23rd. Okay, so when we have a positive coefficient, when we have a positive exponent, that means we're making our coefficient much larger. Okay, so let's look at it again. So we have 4.6 times by 10 to the 23rd. Here's our scientific notation, and then here's our standard notation. And where did we get the 23? That's how many places we moved the decimal. So we have our 4.6 with our decimal place in between the 4 and the 6, and then you're going to count how many times you're moving that decimal until you get to 23. Okay, and we'll look at some smaller examples where it's easier to count those values out. Now, when the exponent is negative, we're taking our coefficient and we're making it smaller. Okay, so one more time. If the exponent is positive, we're making our coefficient larger, but if our exponent is negative, we're making our coefficient smaller. See how that's much smaller than 2? And the decimal places that we're counting and moving it over are going in the opposite direction. So we have our 2 times by 10 to the negative 23rd. We have units attached to that one, so don't forget those units are important. We have our decimal here, and we're going to move that over 23 times until it's on the opposite side of the 2 there. Now let's talk about what we mean by proper scientific notation. Know that these two values, or not necessarily two, the coefficient, like we said, is between 1 and 10. So even though this is the same as 46 times by 10 to the 22nd, this is not proper scientific notation, but this one is, because this value is greater than 10, and that one's in between 1 and 10. Okay, so that's what we mean by proper scientific notation. Okay, this one is not proper scientific notation. Right, use scientific notation, rewrite the following numbers. So we're going from standard notation to scientific notation. Let's work through the first one together, but if you're watching this online, hit pause and then go through the next 1, 2, 3, 4 of them, and then press play again and see if you got it right. Like, use this technology to an advantage, right? You're lucky that we have this opportunity here that's unique, that you get to hit pause and you get to rewind and listen again and all those good things. Okay, so I've written my coefficient in proper scientific notation, a value between 1 and 10. And so I have 3.47. And then times 10, but I need to know what power this is going to be. So my decimal place right now, it's over here. And so I'm going to move this decimal place 1, 2, 3, 4, 5 times. Okay, so I moved it over 5 places, so it's times 10 to the 5th. Is it positive or negative? Well, I'm taking my coefficient in scientific notation and I'm making it bigger in standard notation, so my exponent needs to be positive. Okay, now, again, hit pause, go through, try these out, press play, and see how you did. This next one, here's my coefficient, 9.02, so it's in between 1 and 10. And I need to recognize what my power is. So my decimal place is here, and we're going to move it all the way till we have it at the 9.02 mark. So 1, 2, 3, 4, 5, 6, 7, 8. I move my decimal place 8 spaces. Is it positive or negative? Well, I took my coefficient in scientific notation and it became much bigger, so I have a positive exponent. And then this last one, we have 6.14 times by 10 to the 1, 2, 3, 4. Okay. Now we're going in the opposite direction. We're going from scientific notation to standard notation. Okay, so we have 1, 2, 3. But how many zeros in which direction? Okay, so we have our coefficient and we have a positive exponent, so we want to make this number larger. So we're going to put our zeros to the right of it to make it a larger number. And we're moving our decimal place 5 times. So my decimal was here, and I'm going to move it 1, 2, 3, 4, 5. So I need to add 3 more zeros so that it's the decimal's moved 5 places. Okay. Now same here, 6.806, but I'm going to be making this value larger, 2 times 10 to the power of 6. So I'm going to move my decimal place to the right 6 places. That means I'm adding 3 more zeros. Okay, so my decimal place is no longer there. It's at the end. Okay. Now, what do we mean by times 10 to some power? Okay. So the important thing to recognize when we say times 10 to the power, it's taking 10 multiplied by 10 multiplied by 10 that many times. Okay, so if we have 2.3, like our example here, this is the same. 1.23. Okay, times by 10, times by 10. Okay, 1, 2, 3, 4, 5, and it has a power of 5. Okay, let's look at page 4. Now, we have a similar pattern with our negative exponents. And so, instead of a multiplication, it's a division. Okay, and so we have 1 over 10 is the same as times 10 to the negative 1, or 1 over 10 to the second, the same as 10 to the negative second. You could rewrite this as 1 over 10 times by 10. And you could continue with that idea. 1 over 10 times by 10 times by 10. And that would be a negative times 10 to the negative 3. So keep that pattern in mind. Use scientific notation. Rewrite the following numbers using scientific notation. Okay, so start with your coefficient. Needs to be a value between 1 and 10. And so here when I look at this value, if I'm moving my decimal place, I would stop here, so I have 8.82 times by 10, and then how many decimal places did I move it? Let's see, we moved it 1, 2, 3, 4 times. But is this going to be a positive 4 or a negative 4? We're taking our coefficient and we're making it significantly smaller, so it's going to be a negative value. Same idea here. 5.9, get that coefficient between 1 and 10, and I move my decimal place 1, 2, 3, 4, 5, 6, 7 times. Is it a positive or a negative 7? Well, we have 5.9, and it's getting much smaller, so it would be negative. Now this last one, we have our 4.0, the negative 5th. And then we have some more examples here that I want you to take a moment and hit pause and go through and try those out on your own, and then come back and see how you did. Okay, let's look at these few. So, our coefficient is getting smaller, so we have a negative exponent, and we moved it 4 places to get to that 4.0. And here, our exponent, and we have a negative power, so we know that must be getting smaller, so our zeros needed to be to the left of it. And we move the decimal place 6 times. Okay, same here. We have our power, we have a negative exponent, so we're going to put our 0 to the left, and we moved it 5 places. And again, we have negative values still, so 3.06 times by 10. Let's see how many times we moved our decimal place. 6. Okay, but is it positive or negative? Coefficient getting smaller, so it's negative. And then our last one. And we moved our decimal 4 times. Okay, so now we've worked with positive exponents and negative exponents. And the last thing that we're going to be covering today is how to multiply and divide in scientific notation.